Good morning, everyone. Looks like it is 7:30, so we'll go ahead and get started. So last time we met, we covered how to factor, and we talked about how to factor quadratics, specifically when there's three terms, and the first term has a leading coefficient of 1. And so what we're going to do today is we're going to talk about what do you do, or how do you factor when the first number is not a 1. Now this only works if there's 1, 2, 3 terms. That means it's a trinomial. And we are going to go through the procedure when this number is not 1. Okay, last week this number was 1. Those were pretty simple. So the first step, and I'm going to show you two different methods. So we're going to do this problem twice. The first method is how I showed how to do this for years. And so I am thinking a lot of teachers probably still show this method. So I'm going to show it because this should be review. But I found an easier way over the years. And so I'm going to show you both ways. The first method I'm going to go through a little fast because I don't think it's the most efficient method. So method 1, how do I factor this? First, you look for GCF. You always look for GCF. And I look, they all don't have an X. And then I have 4, 7, and 3 that are what we call relatively prime. So there is no GCF. My next step would be to still make that triangle, or I should call it an X. I don't know where the triangle came from. Instead of putting the 3 on top like we did before, now we're going to multiply it by the first number. So it's going to be 4 times 3 is 12. And we're still going to pull down the 7. You then go through and start thinking about what multiplies to 12 but adds to 7. That would be 4 and 3. And so this method is called factoring by grouping. And so in order to factor by grouping, we have an odd number of terms. We're going to change this into an even number of terms. And the way we'll do this is instead of writing 7x, we'll write it as 4x plus 3x. So let me go ahead and do that. We have 4x squared. And again, instead of putting 7x, we're going to put 4x plus 3x. And then, of course, our plus 3. From here, we are going to divide this in half. And I'm going to look at 4x squared and 4x. And I notice, so basically you cover up this part on the right. You only look at 4x squared plus 4x. What is the GCF? Let me think. 4 and x. What's left over? 4x times x is 4x squared. And then 4x times 1 is 4x. Pull down my sign. And then I look at 3x plus 3 and I ask myself, what is GCF? Well, they both don't have an x, so I can't do that. But they do both have a 3. And what would be left? An x. Because 3 times x is 3x. And then a 1 because 3 times 1 is 3. From there, this should be the same. If they are not the same, you messed up. So in my case, they are the same. So I'm going to put x plus 1. And then 4x plus 3. So notice when a is not 1, it just takes a couple more steps. Now, I found an easier method to get the same result. Remember, the order of this does not matter. So if you put 4x plus 3 and then x plus 1, it is the same factors. It does not matter. So the way I'm about to show you, it actually starts off at the very first step. But from there, instead of factoring by grouping, there's a different method. And I don't even remember what it's called, but it has something to do with sliding. Let's try this again, and we're going to get the same results. Okay, so the first step is the same. You still do 4 times 3. You still put the 7 on the bottom. The magical numbers that multiply to 12 and add to 7 are still 4 and 3. Here is where it's different. Okay? And it took me a couple years to get on board with this method because it's more so a trick, and I don't usually teach tricks, but it's so easy, it's hard not to do it this way now. So you take your variable, you put it with the red. So you put x with the 4, x with the 3. Now, if this was a 1, we would be done. Okay, but because it's not a 1, we need to take into account that 4. And so what you're going to do is you're going to take this 4 and you're going to divide them both by 4. And then from there, this is where it's more so a trick and not mathematical. If it reduces, you reduce it. Okay, so like 4 divided by 4 is 1. If it doesn't reduce or it stays a fraction, then you're going to slide the number in front of here. So if it reduces, reduce it. So there shouldn't be any fractions, is basically what I'm saying. So since 3 over 4 doesn't reduce, you pull the 4 up. So let's see what we get. We'd get x, 4 divided by 4 is 1. And then here, because 3/4 does not reduce, we slide the 4 to the front. And we get 4x plus 3. Notice it is the same thing. Okay, that's what we got a second ago. X plus 1, 4x plus 3. So there's method number 1 and method number 2. I personally think method number 2 is a little simpler. The way I was taught in high school, which is a whole different way, is you take your 4x squared and you start guessing. So you'll say x and 4x, 2x and 2x, 4x and x. And then you take your 3 and you start guessing 1 and 3, 3 and 1. And so you end up with all these possibilities, and then you multiply them all out until you find the one that matches it. That is not a way I'm going to show, but it's a method that does work. You just sit there and guess and keep distributing until you get this back. Now, how do I know if I'm right or wrong? Well, you could. The easiest way would be to distribute this out and go x times 4x is 4x squared. X times 3 is 3x. 1 times 4x is 4x. Add that to your 3x, you get your 7x. And 1 times 3 is 3. Another way would be to graph this and see if they look the same. So I'll do that real fast. So I'm going to graph 4x squared plus 7x plus 3. Now all this will tell me, the 4x tells me it opens up. The 3 is the y-intercept, which of course it is. But in factored form, what I just did, notice they are the same. So that's another way you could check your work, just to make sure that they are the same. Now, factored form or intercept form tells me that one intercept is -1. Notice right here, and I'll zoom in so we can see it better, that one intercept is -1. And then the other intercept is -3/4, -0.75, which, looky there, -0.75. So that's why intercept form is useful. It tells us where it crosses the x-axis. Standard form pretty much just tells us the y-intercept. So we have the y-intercept and then the two x-intercepts. Okay. Let's do one more. And from now on, I'm just going to show you method number 2. 12x squared plus 7x minus 12. I guess that's a 10. They all don't have an x. 12, 7, and 10. There's nothing that goes in those three, so there's no GCF. So I take my 12 times my -10, and I get -120. That's going to be fun. And then I take my 7 in the middle, and I put that there. And now I need to find the combination that multiplies to -120 but adds to 7. I always start with, whenever something ends in 10 or 0, I always think of 10. So what if we did -12 times 10? Well, that adds up to -2. Well, that didn't work. What else could -120? What about 6? -6 times 20, but that adds to 14. What about 8? -8 times 15 is -120, and then 15 plus -8, oh, that's 7. There we go. This one took me a couple more minutes, so you don't have to list out all possibilities. You just need to find the possibility that works. So it's -8 and 15. So again, I am going to only follow method number 2. So I'm going to put my variable, which is not always x, but usually is x. I'm going to put it with the -8. And then I'm going to put my x with the 15. And now you would be finished if this was a 1. If this was a 1x squared, there is your factored form, but it's not. So now we need to divide this term by 12 and this term by 12. Now where did that come from? That came from this. From there, I need to reduce. 8 divided by 12, 4 goes into 8, 4 goes into 12. So that would be 8 divided by 4 is 2. And then 12 divided by 4 is 3. And then 15 over 12, the GCF of that is 3. 3. So 15 divided by 3 is 5. 12 divided by 3 is 4. Now, when you're doing it this way, which totally is just a trick method, but it gets the same result, you cannot leave it as a fraction. So if it's a fraction, you take the denominator and you slide it to the front. So you'd get 3x minus 2. And then same thing with that 5/4. You're going to slide the 4 to the front. And you're going to get 4x plus 5. Now, the easiest way to check your work would be to distribute 3x times 4x, 12x squared. 3x times 5 is 15x. Negative 2 times 4x is 8x. Negative 8x. Negative 8x plus the 15x I spoke of before is 7x. And negative 2 times 5 is negative 10. Or you could take this and graph it and see that there's a graph on top of a graph. And then later we'll be talking about the x-intercepts. The x-intercept of this is 2/3, and the x-intercept of this is negative 5/4. And I'll talk more about how I got that. I think that's the next lesson. Okay. Now, if we have time, I will go and do this extra problem, but there is another method of factoring. And I want you to see the difference here. So we're going to be talking about what's called difference of two squares. So difference means it has a minus in the middle. Now this one's tricky because it starts with the negative, and so I'll show that last. And then what does it mean to be a square? A square is anything that has the same length and width. So like 1 times 1 is 1, so we say 1 is a perfect square. 2 times 2 is 4, so we say 4 is a perfect square. 3 times 3 is 9, so we say 9 is a perfect square. X times x is x squared, so we say x squared is a perfect square. Okay, so when you're factoring these, there can only be two terms, and they both must be perfect squares. So I'll make this as simple as possible. If you think of x squared, and you think of that as a square, that's x times x. And then when you think of 9, and you think of that as a perfect square, that's 3 and 3. Now, if these are not perfect squares, this does not work. And then what do we get? Our answer is going to actually be x plus 3 and x minus 3. Now, why does this work? Well, x times x is x squared. There is no middle term. We need that to cancel. That's part of why we did 1 plus, 1 negative. The middle term is going to cancel. X times negative 3 is negative 3x. 3 times x is positive 3x. Those cancel. And then 3 times negative 3 is negative 9. So that is why we need this to be a negative. Also, is because positive times negative is always negative. So these are actually pretty simple. 4x squared minus 25. If you think of that as a perfect square. Four x squared would be 2x and 2x. 25 would be 5 and 5. And then you just put that together, 2x plus 5, 2x minus 5. Let's do the next one. Perfect square of 2x squared. How do you make a perfect square out of 2? The only way to get 2 is 1 times 2. That would be a rectangle. So this one is not a perfect square. 18 also is not a perfect square. Only options are 2 and 9, 3 and 6. You could technically use square roots, but we're not going to yet. So this one, I could almost put not factorable, but I noticed there's a GCF. And the GCF of 2x squared and 18 is 2. So I'm going to factor out the 2. And now I'm left with x squared minus 9. Well, x squared is a perfect square. That's x and x. 9 is a perfect square. That's 3 and 3. So I'm going to put x plus 3, x minus 3 with the 2. So if you're looking at this, especially in the practice, and you're like, whoa, that is not a perfect square, look for a GCF. And once you find a GCF, usually that factors. Okay? Not everything factors. So there might be some in the practice that are not factorable. Here, x squared is a perfect square. 9 is a perfect square. The issue here is that this is a plus and it has to be a minus. So then we think, well, anytime you have a leading coefficient of negative, you should factor it out. And remember, factoring out a negative negates everything. And now I see that x squared and 9 are squares. I have my difference, so this is difference of 2 squares, and I could put x plus 3, x minus 3. But what do you do? And this is one thing I skipped in the practice the other day. Is there a way to factor this when there's a plus? So notice, all of these look the same, except there's a plus. So is there a way? Is there a way to have opposite x plus 3 and x minus 3, but when you multiply a positive times a negative, you get the positive? And there is. And the way it is you're going to use imaginary. So on this, and I'll just keep it simple, it's still going to be x plus 3, x minus 3, but there's going to be an I right there to represent the plus. So this is going to be x plus 3i, x minus 3i. So you still have x and x is x squared. You still have the middle term canceling. But here, now we have 3 times negative 3 is negative 9. I times I is negative 1, because I squared is negative 1. So you get negative 9 times negative 1, which is positive 9. That's why it works. So to get a positive back, if you put the I there, because I times I is negative 1. Okay, from there, just make sure you know that the minus does not have an I, the plus does. So 4x squared plus 25 is still 2x plus 5, 2x minus 5, but because it's plus, you put an I right there. J, it still has a GCF of 2. And it still factors into x plus 3x minus 3. But because it's a plus, you need the I. And then finally, I still factor out the -1. So I get x squared plus 9. And this still goes x plus 3x minus 3. But because I have a plus 9, I need the I. So I hope you see the difference there. If I totally confused you with the I, no worries. When we're solving these, we could still use the quadratic formula, but it's way easier this method if there's only 2 terms. The most important part is the left side of this column. So the left side you should have seen before, the right side is new. All right, well, are there any questions? If the practice looks just like this, there is a quiz just like this. Good luck to all of you. And I'm going to go ahead and sign off, and I'll sign into the office hours. Hope you all have a great day, and nice seeing you.